Hello all and welcome to my YouTube channel. So today in this particular video, I am going to be discussing about a library called DARTS. DARTS is a Python library for easy manipulation and forecasting of time series, where we can use our time series data and we can use it for predicting n numbers of models like ARIMA, SARIMA, Verimax, neural networks, using NBeats model, transform models. So all such kind of models are being imputed in this particular library, and we can use it directly, like how we do it in the scikit-learn library for machine learning models. So in the similar way, we just have to import the functions import the model as a form of functions, and then we have to just use the fit method and predict. In the similar way, we can do the modeling for time series, and you can use the deep neural networks and the pre-trained models like NBeats, and even you can use transform models. So a lot of models has been directly been imported into this particular darts library. So we'll just go through it and we'll just have a walk through it, like what kind of model it has and what kind of analysis you can do. So in time series generally we have univariate analysis, multivariate analysis, and even multiple time series analysis. So all those kind of analysis, the complicated analysis of time series, can be performed directly by using this dart library. So if we go into this particular documentation of this particular darts library, so you can see there are a lot of things. You can use forecasting models. You can also have data processing for time series, like you want to do some cleanup, you want to do some filling of missing values in your time series. So all such kind of data processing can be applied. You can do the scaling of the time series, and there are various metrics available to evaluate the performance of a model, and even back testing can be done. Regression models are being also been given into this particular library. Like you can also ensemble the models with two or three kind of deep neural network models, and you can just ensemble the models. So that can also be done over here. You can also do multiple time series training. You can also add covariates, like multivariates, into this particular training of a model by using these darts. And you can also have a probabilistic support. That means you can also use probabilistic models to forecast your predictions with you some probability confidence of the range of a particular forecasting period. And you can also have filtering models like Kalman filter, Gaussian process filter, moving average. So all such kind of compatibilities are being given into the starts. So it's like whole package, like how we have in scikit-learn. So in scikit-learn we have a lot of packages of models like linear regression, random forest decision tree, XGBoost, light XGBM. So such kind of models are directly being imported into the scikit-learn. Similar way, we have all kinds of time series modeling being imported into this darts library, and we can just directly use it just by calling it fit and predict. So that's the simplicity of this particular darts library, and we can directly just have to pip install it, and we have to directly use it. So before going into that particular installation and processing of the data set, we can just take a look at what kind of models it has. So we can see it has ARIMA, Varima, Auto ARIMA, exponential smoothing, theta for theta, Prophet, FFT, reintegration models, random forest, light GBM, even RN modules like LSTM and GRU. So we can use LSTMs and GRU directly over here. We have deep AR equivalent to this particular RN model. They have implemented it directly. We have this block RN models, which is generally an encoder model, and it's an NBeats model, which is uh, very good model in terms of predicting the forecasting for the time series. It has won a recent competition in time series modeling as well. And this is a temporal convolution network model in time series and transform model. So likewise, we have enough number of models for time series analysis and forecasting, and you can see that what kind of models capable of predicting. So you can see many of the models are capable of univariate analysis, but some of them all are available for multivariate analysis, and few of them are available for the probabilistic analysis. So likewise, these models are being imported into this particular darts, and we can just directly uh, use this by just importing it from this darts library. And this is what the flexibility of this darts library is, and we can utilize this for our own time series analysis. So if we go into this particular documentation of their darts library, we can see there are a lot of things that can be done. And if you see this data processing, we have a lot of things in here. If you go into this data processing transformers, you can see we can convert into base data transformers, box cause transformations available, scalar, mass mapper, and even a missing value filter are also available. So we can do the transformations, whatever transformation we require in time series analysis, we can do it by using this, just a simple import and from the darts library, and we can just directly use it. Even we have this pipeline, so we can build a pipeline of transformations. Like if you want to do multiple transformation in a continuous way, so we can just use this pipeline function, and we can just directly mention like what are the series of transformations you want to use in the particular in the series. So you can just use this pipeline tool as well, which is very handy tool when it comes to data time series processing. So we have a lot of data sets available here in this particular dart. So you can see we have OSBA data set, air percent data sets, so energy data set. So likewise, we have a lot of data sets available here. Which can be directly used in for our data preparation and practicing. And we have a lot of metrics available in here for model evaluation and training. So you can see there are a lot of metrics like the DDW metrics and even loggers available. You can use mean absolute error. You can use mean absolute percentage error. So likewise, we have a lot of uh, metrics available for evaluating our models. And once you go into this particular model section, you are going to see two types of model. One is filtering models. We have three types of model available here. And if you go to the forecasting models, we have a lot of forecasting models available here. So if you want to if you want to do and implement, let's suppose recurrent network model. So if you go into this particular section, and you can understand how the things work and what are the things required in this particular recurrent model. So we can provide the necessary parameters in it, and we can just work with this particular model. So that's how it is simple. That's how the simple it is. And likewise, you can do it for other kind of model as well. You can use for profit, Facebook profit. You can use transform models. So likewise, all the details are being given. Even you can do the custom provision of the layers by using these parameters in here. So that's how we can just simply import this part of the models, and just we can give our own uh, parameters, and we can fine tune our models. And we have a lot of utils as well available here, so we can do a lot of uh, extra things with our model. Like we can do grid search. So right now it doesn't support random search or any hyperband search or Bayesian optimization for hyperparameter tuning. We can just use grid search here. But in later series of this updations of the starts, they will be incorporating Bayesian optimization as well. So once that is done, once your model is prepared, so you actually want to hyper tune your model with various parameters, and just want to do it. So you can use it in a better way. But here we have just grid search, so you can directly use grid search for now. But in later updates, we're gonna get a few more techniques to hyper tune our models. So likewise, you have a lot of utils over here which can be looked into this. And we have just time series methods which can be directly applied to the time series, like adding values, appending some values, and differentiating the particular time series. And we can use the split methods to split into test and train. You can load time series from data frame from JSON. So a lot of time series methods are also being available over here, so we can directly use it. So that's what the quick introduction of this darts is, and we're gonna be seeing the few implementation of it, like how it can be done. Just a quick glimpse of it. So let us go and uh, let's go to the notebook and start understanding how these darts are being used and how the training of model can be done. So in this particular video, I am going to be using darts for preparing a simple recurrent neural network model. So for this, I have just used pip install darts to install the darts library, and then from here I'm going to import few of the dependencies from the darts, like torch, torch.nn, torch.optim, numpy as np, pandas as pd, and from darts we are just importing time series method, and we're using transformers. From transformers we're using scalar method to scale the time series into a particular range. So that's what data transformer is coming from. And from the darts.model we are going to use rn models, so we are importing rn models functions, and exponential smoothing functions and block rn functions. From metric for evaluation of the time series we are importing a map, which is mean absolute percentage error. So we're going to evaluate the rn model by using this map, and we are going to impute the statistics. Like from statistics we are going to impute check seasonality and plot acf functions to check whether there is a seasonality in the dataset, and plot the acf plots. So for this we have direct functions from this darts, and we are going to use dataset, a common dataset which is generally available in darts, but you can also use your own dataset, which can be directly imported from pandas and can be converted into darts format, which is time series format, which generate darts user. So we have this air passenger dataset, and we can use it for our analysis for now. And darts utils dot time series generation, so this generally help us to generate a custom time series from this particular darts library. So that functionality has also been given to us in the form of time attribute time series. So this is the function that will help us to uh, prepare a custom or synthetic time series. And these are the libraries generally used for the ignorance of the warning, so we can just directly use it. So for now let's run this particular cell to import all the necessary things that we discussed. And once that is done, we're going to use the dataset, the air passenger dataset, which is very common in time series analysis. So we are also going to use that for our implementation of darts. So here I am just loading air passenger dataset and in a form of series. So in this darts, uh, the data is in the form of time series, and actually it is in the form of time series. So if you go into their documentation, you can see this time series. So this is the object they generally take into the place. So time series is the particular format of this particular darts to be in. So that's how, once you have the data set on your own data set, so you have to convert your data set in a form of time series format. So you can do it directly by using this from dataset or from csv, from data frame functions, or you can even use from json, from series. So likewise we have a lot of functions to get this data frame objects converted into a time series object, which generate darts accepted. So that's how we generally do it, and this is what it is doing right now. And then once we have this data set, we'll split into particular train and validation after this particular time segment. So that's what it has been done. So you can see we have this series, and we have provided the method called split after, and we have provided date time. So it will split after, and it will provide the two kind of data frames or series, that is train series and validation series. And now we are going to use scalar function to transform our train and validation data set into the particular scale of 0 and 1. So that's what we are doing here. So we are using this transformer and fitting it into the training data set, and we have transformed it to the scale of 0 and 1. And similarly we are using a validation data set to transform it into a 0 to 1 scale. And now we are just finally transforming the whole series into the scale of 0 and 1. And once that is done, we are going to add more multivariates to this particular series, so that our predictions can be improved. So that's why we are adding up more time series data over here by using this method, and by using this function date time attribute time series. And we are providing some range and frequencies and periods, and then year. So this is what it will create, a new time series for a year. And we are again going to transform it using this particular scalar function, and we are going to add up one more time series, uh, one multivariate, which is month series. So we'll add up this particular line in a similar way how we did it for year. So we'll create one more month series, and we'll convert that as well with in a scale of 0 and 1. And then we'll stack this particular month and year series into one. So stack function is nothing but time series function, which can be generally found in this particular segment where the time series functions are being mentioned. So you can just go and walk through it, like what is stack being used. So it is generally being used to combine these two years and month series to prepare a single covariate series. That's what we are doing it over here. Instead of single series, what we had over here, we are going to add up more data to it, so that we can use it as a multivariate analysis. So we're gonna use this covariate, and we will split it into from the same time zone. What we are doing it from here. So the same we are doing it for the same time that we are doing it, and we will have now covariate train and covariate validation. So we'll have this univariate data, and we have created one more data, which will help to model this particular train data, this particular original data. So that's what a multivariate analysis is. So instead of taking a univariate time series, we are preparing one more synthetic data, and we are preparing for the multivariate analysis. So that's what it is doing. So once our data set is prepared, we will run this particular cell to get the data set prepared. And once that is prepared, we'll call our RN model, and we'll pass some arguments or parameters in it. So we are saying that we are going to pass LSTM, consider an LSTM model, and its hidden dimension will be 20, and we are not passing any dropouts for now. Its dropout parameter is 0. We are giving the batch size 16, and we are giving number of epochs as 300. We are giving the learning rate as 0.003, and we are giving a model name as AR underscore RNN, and we want that tensor board uh, should be coming up. So we are storing the logs for it, and we are providing some training length and input chunk length as well. So these are two very important things that we need to consider while preparing the model. And then we can provide a force reset, and we can use save underscore checkpoints equal to true to save the model. So that's how the parameters are being defined inside this particular model. And if you want to use any other model, you can just have to replace this RNA model with some different model, and it will be and you have to use different parameters with respect to that. And that's how simple it is. So in a similar way how we do it in a scikit-learn, you have to just import the model from the start, and you have to provide this particular parameters, and that's how you will create the model. So right now I've created RNA model with these parameters, and now after this I will just use this model and fit it onto the my train data set, which is train underscore transform. So this is nothing but a scaled version of my train data set. You can see I have prepared it over here, and then I am passing feature covariate series. This is nothing but an extra data, or that is a multivariate. We are trying to create a multivariate time series model. So for that we have created a synthetic data set for us. So that's what we are going to pass it over here in feature underscore covariates while fitting into the model. We are going to pass into this particular feature underscore covariates parameter, and we are going to pass this validation transform data, and we're also going to pass this this particular covariates into this particular validation score future underscore covariate method of parameters. So that's how simple it is to prepare a multivariate time series modeling. So if you just want to do a univariate, so the things are very simple. So you have to just get rid of this particular feature covariates and this particular validation covariate. So you don't have to provide these two things, because in univariate analysis you just have one time series column, and you have to just use it for prediction. But in multivariate we have multiple time series columns which has some dependencies or external factors which actually affect the time series. So for that I'm using this particular covariate. So these are nothing but than extra factors which are actually affecting the time series for prediction or for forecasting. So I have included it by creating it. So if you are using just univariate analysis, you can just get rid of this particular two parameters, and you have to just provide the strain and this transform and validation is a transform, and then you can fit your model. But I just wanted to show you the whole purpose how we can use a multivariate and univariate as well. So for training we have to just fit it, and will take few seconds to run. So let's wait for it to finish for the training. Okay, so model training has been now completed. So now what we can do is we can just run for the predictions and evaluate our training model. So you can see we have prepared a evaluation underscore model function which takes the model, that is the model which we have trained, and it will just take predict method, and it will predict for 26 number of periods, and it will forecast it for 26 number of periods in the future, and it will plot the figure, that is the actual and the forecasted values, and it will as well plot the MAP, which is a metric which we will just use to evaluate. So it will take prediction series what we have predicted, and it will use the validation data for calculating the MAP, which is mean absolute percentage error, and it will just plot it onto the graph, and that's what this particular whole function will do. So we'll just use this evaluate underscore model function to just evaluate our the current training model. So let's evaluate it uh, on our data set. So you can see the mean absolute percentage error is quite low, and we can see the predictions which is in that is the forecasting in the future, which is for the time period 26 months. So from the validation, so this is the black line. You can see it's a validation data set for the same period, and for the same period we are forecasting as well. So you can see the model, our realistic model is fitting quite well onto this particular data set. So that's how we can do the predictions and forecasting. And you can also use this method that is from load from checkpoint. So once you have this well trained model, that is wherever the best checkpoints has been created, so you can load it from your directory. So actually for now I have paused that particular, like haven't given any arguments for saving it to particular local directory, but you can do the same thing here by using this particular load underscore form underscore checkpoint method. So you can load your best model by giving this best is equal to true from the checkpoints that it will create. So you can pass it by using you can save that particular model by giving the parameters like save underscore checkpoint is equal to true while doing this particular while providing this all these parameters into this particular model. So you can save that particular checkpoint, and once the best model that is being trained while we training, it will save it, and then you can load that particular best model, and then you can evaluate it the similar way like how we did it here. And then you can also do the back testing. Back testing generally means let's suppose your this model is not available for now. You must have been using this model 6 months earlier, and from that horizon how our model would be performing till today. uh, so that's how back testing works. So we generally want to test it from the period when we start using the model in the back, during the back time. Like let's suppose a 2 year ago we would have this model, and we would have used 2 years ago data for training that particular model, and then what could have been prediction for the 6 months when we could have used this particular model for training. And that's what historical forecasts help us to tell us. So for forecast horizon, I plotted 6 months, that it will be used for 6 month backtest predictions. And then you can just use this particular historical and forecast method and pass this particular transform series into this. And you can also pass the covariates, and you can just start using the backtesting, and then you can plot the particular graph as well. So once that is done, you can see it has taken 6 months. It has predicted 6 month data, and it has done the back testing from 1959, and it has predicted the data for 6 months from that horizon. So it's like once you had this model in 1959, and then it would have predicted six month data like this. And in that 6 month, you didn't had this original data, so it has predicted quite well, you can see. So that's how a back testing actually generally works. How good is our model when we could have used this in the past. So this is what the back testing is, and this is the exclusive feature of this particular DARTS library. So I generally use it for back testing our model for time series modeling. So I hope you would have enjoyed this video. This is a quite long video, and quite a general video you can understand from this DARTS. There are a lot of things to be covered in this particular DARTS library, and obviously you can explore it. But this was just a general introduction and how the things work over here in darts. You can generally go through it, and you can go through this particular documentation, which has been very good in explaining everything in detail. So you can go through these particular examples and tutorials, understand everything what every part of this darts library does. It's pretty simple, and it can be understood very easily. So this is all about this particular video. I hope you enjoyed it. Thank you.